Hey, what up guys? My name is Mohammad Mehdi and today I'm going to be making an LED clock. Now a while ago I found this tutorial on the internet on how to make an LED clock with ping pong balls. Now since I live in Iran and in Iran buying a lot of ping pong balls is expensive. I mean you could get them for cheap if you want to play actual ping pongs, but buying 128 ping pong balls is really expensive here. So I came up with an alternative which I think is much better in terms of cost. So credits to that guy with the other tutorial on Instructables, but I'm going to be making my own version. In order to make the clock, you would need an Arduino. An Arduino is something like this. You see, it's an electronic board which is programmable using a computer. It's not very hard, and we're going to be using C++ and some other commands which you're going to be seeing later on. You would need a clock module. This thing you see I have here is a DS3231 RTC module, which is in charge of your time. It's basically your clock. So if you want to set the time, you do it with this. Now you might ask yourself, how does one make an LED clock without LEDs? The answer is one doesn't make LED clock without LEDs, because in every LED clock you would need quite a few LEDs. This strip of LEDs I have here is a really cool set of LEDs because of a few reasons. First off, they're RGB, meaning that they can emit any color. You could have green, you could have red, you could have violet. Another good thing with these LEDs is that you could control all of them, all 150 of them, with just one data pin, which is really convenient because you wouldn't have to have wires for each of for every single LED. You would just control the whole thing with one data pin, which is fascinating. You would need a breadboard, something like this, to assemble your circuit on. You would need jumper wires, these connector things, to make your circuit. This is a male end, this is a female end, and you would need different types, like male to male, female to female, male to female, so that you could make a really good circuit. You're also going to be needing a plate of MDF or a plate of anything, basically, to keep your clock elements on. This one is a board of MDF, which I'm going to be using. Now, this one here, we call it talq duri. So if you're a Persian speaker, now you know what that means. However, for you non-Persian speakers, it's something like plexiglass or acrylic. I'm not sure if you can exactly use those as alternatives. However, you would need something to diffuse the light, so the light emitted from the LEDs wouldn't be so pointy. You would get some dispersion. And that's about it. You would need some tools, which I'm going to be explaining later on. You would need some resistors, not a lot of them. I mean, 220 ohms are going to work. As you can see, I have marked my plate of MDF using this paper tape. They're really good stuff. You can buy them at the pharmacy. And I have marked the outline with a marker so that I would know exactly where to cut. As you can see, I'm cutting the board using a saw, and it's such a shame that the university doesn't let me use theirs. I mean, like, whatever. Now that you've got past this level, you'd have to strip the plastic off the LEDs so that you could install the LEDs on the board. Let's get to it. Strip the plastic off, it turns into something like this. You see that? So now what you have to do is to cut them into segments of 17, 18, 19, and 20, and then 19 and 18 and 17, so that you would get 7 rows of LEDs, a total of 128. Is it down to something like this? Notice there are the 17 length at the top and the bottom, and then the 18 ones and the 19 ones, and the 20 strip in the middle. And they do get twisted, so be careful with that. Now I would have to mark where they're actually supposed to be and then stick them on permanently. This is just so that you know how it's going to look like. I have stuck the LEDs on, as you can see, and I have done some soldering. If you look closely, you can see that at the end of every LED strip, there are 3 pins. One is the 5-volt pin, one is the data pin, and one is the ground. So what you need to do is that you follow the direction. You see the pointer here? You follow this direction, and then from right to left, and then from left to right, and then again from right to left, and then again from left to right. You start from the top right corner, and then you solder the 5 volts to the 5 volts, the data pins to the data pins, and then the ground pins to the ground pins. And at the end, you would need to solder the data out to the ground so that it would be connected. What you can also do is to solder female connectors at the beginning so that you would have no trouble with the circuit. You could also use hot glue gun for more mechanical stability, which I'm going to be doing. So we talked about the board, we talked about the LEDs, we talked about how you're going to be making all of that. I will be talking about the electronics soon. However, one other thing that I would like to talk about first is the programming. In order to program, you would need to have an IDE, which is this program here. You put your code in it. First, you need to download it. So in order to download it, you go to the Arduino website. If you search it, it's gonna be coming up, and inside the software downloads. Here you can see the different versions of the Arduino IDE depending on your operating system. You can install any one of them. It's got versions for Linux, Mac, and Windows. If you have Windows, please use the installer, because this link goes to the Microsoft Store, which is a really bad imitation of iTunes. I mean, it doesn't even work. So if you're using a Mac like me, you can click the Mac button and it goes into the Mac. Here you can contribute as much as you want, or you can just not contribute and download the whole thing. So you can see that it's being downloaded here. I will skip the downloading bit because I have it already. Right, we have now downloaded the Arduino IDE. Let's see how it works. I'm opening the IDE and it takes a while to load. While this is loading, I'll tell you some things. This is programmable in C++. It's basically the same thing but different commands, different functions that you need to control the board, because it's somehow different from programming a computer. This is the function setup. This is the function loop. The function setup is run once. So if you need to do anything, any sort of initialization, any sort of setting, or like giving values to variables, things like that, you would have to use the function setup. And this one is the function loop. This runs over and over again. So let's say in the function loop you assign the value 1 to some random variable. It keeps doing that repeatedly. Now let's see how the code that we're going to use works. This is a library that we are going to be using. It needs to be in the same folder as the code. You see, this is the code, this is the library, and we're going to be announcing this library into this code. Right. There goes the code. You see, this is the library of related to the LED that we're going to be using. This is the pin that we're going to be using for the, see, this is the same data pin that I showed you on the LED. I'm going to be showing it to you again in the electronics. This is the number of LEDs that we're going to be working with. It's 128. This is an array of colors. It's an array with colors as values. For example, LEDs 0 might be green, LEDs 2 could be red, LEDs 111 might be white. This is an array with a specific sort of type. This is a color that we're going to be using in our code, and this one too. This is a library. Do you remember the one I told you that we're going to be adding later? This is the library. And this is an initialization code for this library. This and this are codes for the RTC, the clock module. Time, t, is an initialization variable for time. We're going to be storing time in the variable t. And h and m are some random variables. And so are these. These are the time digits. So let's say the time right now is like 3:30. This would be 0330. These two are the hour digits. These two are the minute digits. This is a position matrix. It's supposed to define the position of the digits on the LED boards. Do you see these numbers here? These are codes for the position that the digits are going to be there. And these are codes for the numbers that are going to be inside these digits. This function deals with setting numbers to specific positions. For example, let's say time is 3:31. You want to set digit 1 to position 3. It starts from 0, 0, 1, 2, 3. You want to set digit 1 into position 3. So inside the function, you would type 1 into position 3. That's how it's going to work. And you would need to change the color hue every once in a while, every few milliseconds. This is the function that deals with changing the hue. This is the setup function that I talked about. The first line is initialization for the LED. The second line is initialization for the RTC. If you want to work with the LEDs, you deal with this. If you want to work with the RTC, you deal with this. And for the first time running, you would need to set the time on the RTC so that it shows the time. This is the loop function that's repeating over and over again every few milliseconds, depending on the commands that come inside the loop. They also take some time. You get the time from the RTC, you store it in the variable t, you store the hour into the h, you store the minute into the m. You can change the color of the board repeatedly. These two lines are the two dots in the middle of the clock. The ones that blink every second. There are those. These four, the Q, Q, W, E, R, are the digits which I talked about. Let's say time is 3:33. The first digit must be 0. You see, it's got a 0 here. So what you need to do is, if the hour is less than 10, the first digit would be 0. This is the purpose of this line of code. And the remainder would be the other digit, which goes into position 1. and the same thing happens with the minute digit. And then you use the function which I explained earlier to set the numbers into the specific positions. For example, time now is 0334. You would set 0 into position 0. You would set 3 into position 1, 3 into position 2, and 4 into position 3. And using this function, you are telling the Arduino to show the LEDs, to light up the LEDs with the new data, which we have used in the matrix. And this last one is a global command which you can use in Arduino to delay, to wait a few milliseconds. I have used 100 here, which means wait for 100 milliseconds. You don't need to do it, it's just something which some people like to do in order to be aware of what's happening. So there goes the code. I will be putting out the link somewhere on GitHub probably. Now let's go over to the electronics. You have now finished your code. You need to upload this code into the Arduino using this USB cable. You stick this end of the cable into the Arduino. You stick the other end into the computer. You go up here and you press upload. You wait for it, and when you see the message done uploading, you know that you've done a really good job. So hey, like I said, this is a breadboard. You see the 30 pins here, which are all connected together in a line. You see the minus? This is our ground reference, 0 volts. There are also another 30 of them, the pins, which we're going to be applying 5 volts to them. You see the plus? The plus means the 5 volts. And the same goes with the other sets of 30 rows. Over here, you see each of these rows of 5, they're all connected. So if you connect a pin to this first one and to this fifth one, these two are connected. But if you connect them like this, these two are not connected. So there goes the breadboard. You know how it works. This is the Arduino. You can see that from here to here, these are the digital pins. They handle the digital data, or PWM ones, depending on your Arduino. These are the analog pins, which we're not going to be using. These are the power pins. You got the 5 volts, 2 grounds, and one other pin, which we're not going to be using. And these are also some other digital pins that you may find in more complicated projects. The pins that we're going to be using is pin 7 digital. You see, remember the digital pin I talked about with the LEDs? We're going to be sending the LED data through pin 7 digital. We're going to be using in the communication pins, the first one, which is pin 21, and the second one, which is pin 20, the SCL and the SDA to transfer data for the clock module. In the power row, we're going to be using the ground and the 5 volts. The Arduino needs power. This is the clock module. This also needs power, and the LEDs also need power. In the clock module, you see, when you look at it from this angle, the first pin is the ground. The second pin is the power. You can either power this module with 5 volts or 3.3 volts. This is pin 1 and 2. Pin 3 and 4 are SDA and SCL, which we're going to be using as with the communication pins on the Arduino. And yeah. So this was the board. This was the RTC. This was the breadboard, and these are the LEDs. We're going to be connecting this to power. this to power, this to power, and establish a connection for data between the LEDs and the Arduino, and the RTC with the Arduino. So let's first connect them to power, and then we'll get on with the rest. These are the jumper wires related to power. The red one is GND, which is the minus on the breadboard. The brown one is the 5 volts, which is the plus on the breadboard. You connect them together like this. Right. This was the RTC. Like you can probably see, the green one is the GND and the yellow one is the VCC. So you connect the green one to the minus and the yellow one to the plus. You have connected the RTC and the LEDs to power. Now, you need to connect the Arduino itself also to power. You take a pair of jumper wires, you stick it in. You see, the orange one is 5 volts, the yellow one is ground. So the orange one goes for the plus. Like, it's a little tricky. Like this. You have connected these three to power, which I'm going to be supplying in a while. Before that, I need to establish the connection, the data connection between the RTC and the Arduino. Like you can see, you need to connect the SDA, which is the red pin, the red jumper, to the SDA on the Arduino, and the other pin also to the other one. Goes in like this. You also need, remember the pin 7 digital I talked about? This is how it gets connected to the LEDs. So you just stick this one in to pin 7. There goes your wiring. Now I'm going to be connecting my power source to my breadboard to power the whole thing. In mine, yours could be different. This one is the plus, and this other one is the minus. Should be going in. So now, like you can see, the board has lit up. You can't see it really clearly because we have not used the plexiglass, but it's working. You see the 1, 7, the 2 dots, 0, 9. Time right now is 5:09. You do remember how I talked about you need a light diffuser so that the light emitted from the LEDs wouldn't be so pointy, wouldn't be so concentrated, and you would want it to spread over a specific area. And I said that you could use plexiglass. I have my talre duri right here. I have cut it according to the dimensions, and no, I don't have corona. And I'm going to be using this to disperse the light of the LEDs so that it looks better. So let me just turn off the lights, and I'm going to be putting this on so that you can see how it's going to be. Right, now I'm going to be putting this on there. And let me show you how it has become. It's become something like this. And yeah, that's how it looks. It's 5:10 p.m. right now. And you can see that the digits are white. So the background is a rainbow sort of a gradient, which changes color every, I don't know, like 5 seconds. And yeah, you could use any other sort of diffuser. Oh, and also one other thing, I will be uploading the blueprints, the CAD files for SolidWorks, so that you can see how it's been designed. It's a reference for your dimensions and position of, the parts and bits and pieces. You can use those. And I will be uploading the code and the libraries There's actually one library which you're going to be needing, and I think that's about it. The link goes in the description. Please subscribe, and I hope you have a good day.